Okay, so in these chapters, what we're going to be looking at is the atom itself in the periodic table. So we're going to be focusing in on classification of matter, which is what we finished up the last sections with. And then we're going to simplify that into substances. So that means we're going to be focusing on our elements, and we're going to be talking about elements and symbols, and of course how that relates to the periodic table. And then we're going to get into atomic structure. So we'll look at the atom, atomic number and mass number, isotopes and atomic mass, electron energy levels, and periodic trends is how we'll finish this off. So we'll start to see how the patterns are arranged starting with the periodic table. All right, so if you remember when we were talking about matter, we said that matter was anything that contains mass, right? Which meant we can break that down into two things. And hopefully you recall that was substances and of course mixtures. And now what we're going to do is we're going to isolate substances and then kind of go into the next piece, which we said substances would be elements and compounds. And so in this section, we're going to be focusing on those elements, right? So elements and compounds make up mixtures, but our focus is going to be on those elements. So how do we keep track of all this? When we talk about elements, if you remember, are the simplest, pure kinds of matter that we have. And so if we grab our periodic table, that periodic table is, the title is actually periodic table of the elements. So all those pure elements have been listed out on that table for us. And when we look at the periodic table, there's a lot of information there. And so the first thing we're going to focus on are the symbols. So every element has a symbol. And the symbol consists of a capital letter followed sometimes by a lowercase letter. Okay, but a symbol always has a capital letter first. So in this case, we're looking at any symbol X here. And then of course, the second letter would, if it's a two-letter symbol, would be a lowercase letter. This way we can tell when we have different elements lined up because we'll have a capital letter differentiating for each element or each atom that's in that formula. Now, here you can see it contains the symbol of the element, the mass number, and the atomic number. So the mass number, we typically, if we're going to write this correctly, then what we do is put the mass number up on the top and up on the left, whereas the atomic number will be down on the bottom left. Now notice we've left the space open on the top right and the bottom right. They have specific things that go here as well. So here is going to put the ionic charge. Now, at this point in this course, we're going to be talking about just neutral atoms, and we'll be adding charges in later chapters. So for now, this is going to be an understood 0, and so we don't write anything there when it's an understood 0. Okay. So from that symbol, if we pick a specific element, we're going to be able to figure out how many protons are there, how many neutrons are there, and how many electrons are there. So all three of these pieces of information are going to come from that atomic number and the mass number. Now the atomic number is just a list number. So for instance, hydrogen is the first element, and so it's number 1. And then we'll have number 2, which is helium, then 3 lithium, so forth and so on. So it's 1, 2, 3, 4, 5, 6, 7, 8, right on down the list. Now the mass number is going to vary a bit. Now the mass number and the atomic number, one way to keep these straight is that the mass number, by rule of thumb, so this is not a guarantee, but by rule of thumb is twice the size of the atomic number. Another way to pick this out is that the atomic number always has to be a whole number, whereas the mass number could be a decimal number. Now, let's pick on a symbol. So I'm going to pick out fluorine 19,9. And so the 19, remember, is the mass number. The 9 is going to be the atomic number. With these two pieces of information, we'll be able to figure out these other three things. So the number of protons is always going to be equal to the atomic number. In this case then, for fluorine, that's going to be equal to 9. The number of neutrons is going to be equal to the mass number minus the atomic number. So if we come back down here, we know the atomic number was going to be 9. The mass number was going to be 19. So if we subtract those two for this particular element, we're going to have a fluorine with 10 neutrons. Now for the electrons, remember we said the charge would be here. Well, what we're going to see later is that charge is going to be equal to the number of protons minus the number of electrons. Now remember, all of these atoms so far are going to be neutral, so that means the charge is going to be equal to 0. And if the charge is equal to 0, and the protons are equal to the atomic number, which is 9, then what will I subtract from 9 to get 0? Well, that'd be 9. So in this case, we're going to have 9 electrons as well. So that's your general formulas here to figure out the number of protons, neutrons, and electrons, atomic number, mass number, and then of course if you have different pieces of these information, so you can actually figure out charge or which atom it is. And we'll do some practice problems here. So let's give this a try again, except this time we're going to be looking for the same pieces of information, protons, neutrons, and electrons. We're going to get them from the atomic number and the mass number, but I'm going to change the elements up, and we're going to use bromine 8035. So go ahead, give it a few moments here, pause if you need to. All right, so if you did pause and you worked it all out, now it's time to see how you did. So again, we're going to say the number of protons, number of electrons, atomic number, and mass number. So the first thing is, hopefully you didn't get these two confused. The atomic number is 35. Mass number is going to be 80. That means the number of protons is also going to be 35. The number of neutrons will be 80 minus 35. That's going to give me 45. And the number of electrons, since we don't have a charge, is also going to be 35. All right, how did you do? Hopefully you did well. And if you struggled with that, again, this would be one of those things you want to get down, because we're getting into chemistry now, and these are the building blocks. So you're going to have to be able to pull that information out and use your periodic table to help you with that. And so moving forward, if you're not getting this, let me know. Typically, students don't struggle with this part, but if you do, and you're a little confused, and it's just a matter of figuring out what is what, again, make sure you get a hold of me. We can set up a Zoom, or we can meet in person, something along those lines, to make sure you're getting this, or you can meet with your tutor. All right, now, using those same pieces of information, I can change up the question. So here we have, if an element has an atomic number of 34 and a mass number of 78, what is the number of protons, number of neutrons, the number of electrons, and now I'm going to change it up. Instead of giving you the symbol, I want you to give me the complete symbol. So again, if you want to pause it now, go ahead and give the video a pause, work this out on your own, and then hit play. Now, for the answers, what we're looking at here is we have the number of protons. We know is going to be equal to the atomic number, which we're told is 34. The number of neutrons will still be the mass number, which we're told is 78, minus the 34. So this time it's going to be 44. Doesn't say anything about the charge of this atom. In fact, it says an element has. So the fact that it's an element means it's probably neutral, which means the protons and the electrons will be the same. And last but not least, we have the complete symbol. So to find out the complete symbol, what you're going to want to do is go to your periodic table, find the symbol for the number. Now, which number do I use? Do I use 34 or do I use 78? So let's grab a periodic table. And if I look at number 34, I get selenium Se. If I use the number 78, well, let's see, 78 as a mass number. I don't even see a 78 as a mass number. I have 78.96, which is also selenium, and I have a 74.92. So hopefully you've wisened up just by that, and you know that you want to use the atomic number to figure out what the symbol is going to be. So for the atomic number, then the symbol will be selenium, Se. And again, capitalization is going to matter here. So I have a capital S, lowercase e. The mass number is going to go up on the top here, so that's going to be a 78. And then on the bottom will be the atomic number, 34. All right, so hopefully that made sense. You went through that and it wasn't a problem at all. If you need to rewind it, go through it another time or two until you get it. But hopefully you're catching on pretty quickly to this. And again, these are building blocks. So if you're not catching on, you do need to practice. We're going to be going back to this over and over and over again. I think I've said it before, but if not, I'll reiterate it now. Chemistry is very different than, say, an English class. We don't learn chunks and then forget it and move on to the next topic. Here, you're going to have to learn something in this chapter. We're going to need that in the next chapter where you'll learn something new. Then you're going to take these 2 chapters and use that for the 3rd chapter. Then those 3 chapters to the 4th chapter. So it's just a building series. And so if the weak, if you think about building a wall, if the bottom layer is weak, the whole wall is going to be weak. And we don't want that. We want you to have nice strong layers going forward. So with that in mind, we'll do some more practice to make sure we're getting this down. If an element has 91 protons and 140 neutrons, and I'm going to give you the same question. We're going to have to make the assumption here that we have a neutral atom. That's going to be the key. All right, and of course, at the very end here, you'll give me the complete symbol. So hopefully you didn't put that periodic table away just yet. Now, if an element has 91 protons, then we know the atomic number is going to be 91. The mass number here, now this time they didn't give us the mass number, they gave us the neutrons and the protons. So we're simply going to add those 2 together. So 91 plus 140 is going to be 231. And again, the number of electrons, since we're not told anything about the charge, we're going to presume that this is neutral, which means we're going to have 91 electrons as well. And now I want to do the complete symbol. And we know that this time we're going to use that atomic number. So I'm going to go to my handy dandy periodic table. I'm going to find number 91. Now here it's a little weird because it goes 87, 88, 89, and then there's nothing. Well, notice it says AC and it turns green, at least on my periodic table. Yours might not do that. But if you look down at the very bottom, you'll see the numbers continue. So you have 88, 89, 90, 91. And 91, the symbol is PA. And that's not Pennsylvania, though. I believe that's protactium. So PA. And so now we have 91 is our atomic number, so that'll go on the bottom. And then we calculated 231 to be the mass number. And if I look at my periodic table, for my particular one, it's 231.04. Now, I don't want to add that 0.04. Whenever we're doing complete symbols, we're looking at what's going to be called specific isotopes, and we're going to get into that in a little bit. So for right now, what you're going to do is just make sure you're adding these numbers up in order to get your number of neutrons and your atomic mass. Okay, so you're using addition and subtraction of whole numbers. All right. So we'll do one more here and put all that information out. I'll give you a few minutes here, so I'm going to pause. This time we have 78 electrons. We're going to say that's going to be equal to protons, which is going to be your atomic number. Use your periodic table to find number 78. That's going to be platinum. And there you go. So hopefully you got platinum 195. All right, so those are symbols. Hopefully you're knocking that out of the park. So as we're looking at the periodic table, we've probably already noticed that a lot of the masses on the periodic table are decimal points. But I just told you you're going to be using whole numbers when you're calculating, which means you can't get a decimal point when you're doing the addition. So that just begs the question, what do I need to worry about on this periodic table? How much of it do I need to know? Well, the first thing I'm going to tell you is do not memorize your periodic table. You will be able to use your periodic table whenever you're doing anything. So if you're here taking a test in this class, or you're on the job and all of a sudden somebody wants to know what the mass of carbon is, I don't expect you to know that stuff off the top of your head, right? You'll just need to be able to use that tool, the periodic table. So as we look at then the periodic table, what is it I do need you to know about this periodic table? Well, number one, it is all pure elements. So in order to get on the table, it has to be agreed upon by a bunch of chemists on which ones will be real elements, and there's a set of rules and a whole bunch of stuff that in this course we really don't care about. So what is it you do need to know about the periodic table? All right. Number one, your periodic table is broken down by horizontal rows called periods. There are 7 of them. Now, this is not a color mix-up. Here we got a kind of a purplish color, then a bluish color. Down here is a purplish color and a blue color. And that's because this is going to be period 1, period 2, period 3, period 4, period 5, period 6, and this is also part of period 6. And if you remember, we did that PA where the numbers were messed up right there. All of a sudden, they just jumped way down here and started to keep going here. And that's because this is period 7, right, all together. Now, my picture here is a little outdated. The new periodic table actually completes down here as well, so we'd have to move these a little further down. But again, for a general chem or a basic chem, we're not going to be worried too much about that. All right. The vertical rows are called groups, okay, which is our columns. So groups run top to bottom. So this would be group 1, 1A, okay? They're also called families, and so you're going to have to know some family names. So the first way we're going to number them, and there's several ways we can do it, is sort of like this. We're going to say, okay, this is group 1A, right there. Here's group 2A. Now notice I'm going to skip all of this. I'm skipping all the way over. This is boron B, so if you're looking at a periodic table, that's where I'm at here, and this is going to be 3A, 4A, 5A, 6A, 7A, 8A. We also call this 0. Now, we can also use Iupac numbering, and you'll see that happen where this will simply be 1, 2, and then it keeps going here. This will be 3, 4, 5, 6, 7, all the way across to 18. So you can number it one of 2 ways, 1 through 18, or you can use the A-B referencing. Okay, now the A-B referencing is talking about the difference between representative elements, which is what the focus of our courses are going to be, and transition elements. Okay, so the B elements here are called transition elements or even transition metals. Now what's funny is that these are down here are called the inner transition elements, and realistically we should almost break our periodic table here, slide it all down, and then fit these 2 in. Now we don't do that because the table would get really, really long and then kind of, weird looking and won't fit on a piece of paper correctly. And so really this is just logistics. Okay, so don't get too caught up into that. Now your family names that I need you to know, group 1A are called the alkali metals. Group 2A are called the alkaline earth metals. 7A, all the way to the other end, is called the halogens. And that last group, the 0 group, you probably already know, most people do when they come into my class, it's the noble gases. Now the last thing, and probably the most important thing I really need you to know about your periodic table, are the differences between the metals and the nonmetals. The difference here between metals and nonmetals is going to distinguish our bonding as well as reactions as well as naming. So this is a huge piece. So you really got to get this down. So metals are going to be everything on the other side or the left side of what we call the stair step. So a lot of periodic tables end up with a real bold line, kind of cuts right on down, something like that. Okay, so when I'm looking at the one that's in my textbook here, it's actually a black lines that are outlining all the elements and then a bold white line that's cutting it down. And the reason why they do that is because everything to the left of that line is going to be a metal and everything to the right of it is going to be a non-metal. Now that's not quite true, kind of telling you a small fib here. But again, it's a general and basic chem, so we're not going to worry too much about these types of little lies, but I'll explain this lie here in a second. All right, so transition metals here, hopefully that'll help you remember, right? Because we said these are the group B elements, they're the transition elements, and they're actually transition metals, and so they're on the left side. So hopefully that'll help you a little bit there. Now, the lie I'm telling you is everything on the right side I said was a non-metal. Unfortunately, that's not quite true. There are a group of elements that kind of fit in the middle here, and we call those semi-metals or metalloids. Now in our course, we're not going to be taking a look at those. We're going to be treating it very cut and dry. So that stair step line that I put in will truly be a divider for us. Okay, so as we're moving forward in this course, everything to the left is going to be a metal and everything to the right is going to be a non-metal. And so these in the middle here, we're going to be treating as non-metals. And of course, I'm going to have things in place that you don't have to worry about this little lie I've told you, but I don't want you to run around thinking that that's completely true. We're just trying to make it as easy to understand as possible. So again, that's our periodic table, that's our symbols, and how to figure out the different particles. Next, we're going to be talking about atoms and their structure. So we're going to take a break here because that's a 20-minute chunk, and again, I don't like to go over 15 minutes. And so this will be where we stop for chunk 1, and then we'll pick up with atoms and their structure in the next chunk. All right, stay tuned.